Thanks for the invitation here and your time this morning. It's a beautiful building here in Banksia, and it was nice and handy for myself and Hector this morning as well. We just live in Mont Chiara, so it's a nice short drive for a Saturday morning. As mentioned, I look after what we do from our architectural specification support-wise for USG Boral across our 12 countries. We also, I'm part of the technical team that looks after major projects. So we've got people here in KL, but we also have fire engineers, structural engineers, and acoustical engineers based from here, Bangkok, Seoul, and Shanghai in Australia to look after major projects. So the talk we're going to give today is just on hotels, and we've been doing a lot of work in the region over the last couple of years in the hotel design in Southeast Asia. There's been a massive spike in the actual number of 4- and 5-star hotels being constructed. And we particularly see that around Vietnam and Indonesia and Malaysia as well. And with that is becoming a more and more requirement for our customers and guests to have a good experience. So everyone these days has a smartphone. And everyone is a critic and everyone is a reviewer. And I know myself personally, when I'm looking at a hotel or where I'm going to go on holiday, the first thing I check and my wife checks is the star ratings and the reviews in like TripAdvisor and Bookings.com. So, the guest experience is probably even more important these days than it has been in the past. So there's a lot of attention from an interior design and architectural point, getting the finishes and the look and the experience of these hotels to be perfect. So, beautiful rooms, a lot of time spent on material selections, color palettes, the overall experience and the look. But sometimes we do see when we work on these projects, is something being missed. And again, if we look at social media, what we do see is quite often complaints. So complaints about the acoustics, hearing through the walls, hearing people in those rooms next door, the soundproofing not being designed that well. And also even getting into these days with connectivity. So Wi-Fi, poor connection. So what we're going to talk through this talk is, well, how do we improve, or what are the different ways to look at acoustics? There's thermal, there is Wi-Fi propagation, it is becoming a big thing these days, especially with speeds of internet increasing, and productivity and the speed of construction. So those are the topics I'm going to cover. So we talk about acoustics, we're talking about sound. There's all different types of sound and acoustics. So we've got external sounds, we've got traffic, we've got aircraft, we've got people's general activities. Actually, just last week we had a trip in India and we had a couple of big projects there. And the hotel I was staying in was a 5-star hotel in Delhi. But I don't know if you get who's been to India, but they love their horns while they're driving. And there was so much road noise coming in through the windows of that hotel and the external facade. So external noise can be a big factor, but also the internal noise within that space. So, people doing different activities. So we look at 2 different areas when we're talking acoustics. And every noise has a different frequency range as well. So not one solution meets everything. So when we're talking about acoustics, there's really 2 main areas that we're looking at. So there's sound insulation and sound absorption. When we're talking insulation, we're talking about the actual reduction of sound traveling from one room through to the other, one area to the other. So from a source room coming through the partition, whether that be a masonry partition or a drywall partition, a lot of that sound is reflected back into the space. Some of it is absorbed by the partition, and then we measure what comes through into the other side. The other part of sound we're looking at is absorption. So this is where we're talking more about reverberation, and we're talking more about reducing the amount of echo, the amount of reverberation that's happening within a space. And when we look at that, we test for absorption, we talk about NRC, or noise reduction coefficient. So in that area, we're talking about how much sound will be absorbed. And for partitions and sound insulation, we're generally talking STC. And that can change between countries depending on what standard they're using. So if we're in Australia or New Zealand, we were using RW, which is a weighted index, or in through Asia and North America, STC is our main measure. So when we talk about measuring that the insulation of a wall and how much sound will be blocked, really there is there's actually three main areas that we look at across the frequency range. So on this little graph here, the y-axis is a decibel reduction, and the x-axis is the frequency range. And generally for walls, while for STC, we measure from 125 hertz through to 4,000 hertz. And the first part of the lower frequencies, the stiffness of the material is what affects how much sound's going to go through. Then we get to the resonance, which is any echo within the space. And then we get to Mass law. So Mass law basically says that you need to double the mass to get a 6 dB improvement. And that's your mid-range frequencies. And when we get up to the higher frequencies, we get what they call the quiescence region. And what that is everything has a natural harmonic. And what you find is at a set frequency, the wall material will match, the harmonic of the wall material will match that frequency, and sound will pass through. So if we're looking at traditional construction, we're looking at, say, masonry, brick, or AAC is quite common these days, really the only thing that is to play with is that mass, right? So what we can really do is increase the mass. And we need to double, Mass law tells us you need to double the mass to get a 6 dB improvement. So what you end up with is thicker and thicker walls. The other thing you can do is create an air cavity and have a double skin masonry wall, but there are still limitations. Now, using other materials, what you can do with material science, people can do, and our acoustic engineers, is play around those different materials. So the stiffness of the material, the cavity size gets us into the next section. Using insulation, using the mass of the board, and using different layers of board really helps us in that coincidence region. So what it allows us, with some different materials, like drywall, steel stud, insulation, we really can mix up that system to really improve the acoustics, where we're talking traditional, all we really can do is increase the mass. So from a technical point of view on how do we measure this, this is all measured in a lab. We do a test to an ISO standard. ISO standard sets the room configuration, and the test method is an ASTM for STC. And generally what you would find is what you have as a actual test result will be different than what you measure on site. So generally there'd be a 5 decibel reduction for what actually happens on site compared to what we test in the lab. So if you're looking at achieving a specific STC rating, what you actually will experience on site will be 5 dB less. So if you're looking at an STC 55, the actual experience on site would actually be more like 50. So what is, we talk about STC and we talk about, the different levels, but what does that actually mean? Sound is very subjective. So here's a little graph, just give an idea. If you have a petition and it's rated at an STC 35, normal speech, you could hear normal speech. You could quite easily hear people talking in the room next door. STC 40, you can hear loud speech, and normal speech would be heard but not really easily understood. 45, loud speech would be heard, but you'll be finding it harder to understand that sort of normal level. STC 50, some loud speech would be heard, but not that much. And 55, really you're not hearing any loud speech. But low frequency noises would generally still be heard. So if you've got a situation where there's a lot of low frequency noise And we see that in residential construction. Everyone these days, everyone has a home theatre system. Everyone has, superwoofers and low frequency noise producers in their space. So that's always a consideration to take into account, especially if you're doing residential construction, that having that wall also designed to help reduce the low frequency sound. So SDC 55 is going to give us good control, but it actually will not do very much for that low frequency noise. And just again, the sound is very subjective. A 10 dB change would actually sound twice as loud or half as loud, depending which way you're looking at it. If you get a 5 dB change, you're clearly going to notice that change. A 3 dB change in a system would just be audibly, you'd best be able to perceive it. But it will be a very slight change. And a 1 dB change is really inaudible. You could pick up it on a frequency change, but from an environment, if you're getting a 1 or 2 dB change, the human ear can actually pick that up. So really, 3 dB and above is where you really start getting an effect. And when you get to 10, you're actually doubling the effect. So when we talk about hotel construction, we're really looking at 5-star, 4-star, and 3-star hotels. And in some markets, some places we've still got 2-star hotels as well. And in there, the hotels, particularly international hotels, what we see is they have very set specifications on the hotel performance, on the finishes, the way the standards for that hotel. But generally, they will also have very set standards on the performance, so the acoustic performance, the room-to-room rules, room-to-corridor, into the service shafts as well. But what we are seeing more and more is that because of the customer experience and things like Bookings.com and TripAdvisor, that even 3-star hotels are adopting 4 or 5-star hotel acoustic standards. Because really that guest experience is important for business. So if we look at a common requirement for a 4 or 5-star hotel, what we see is the between rooms, the room-to-room walls generally is a 55, an SDC 55. If we're looking at rooms between a room and a corridor, we're looking at SDC 50. And also what we're seeing is service shafts sitting around about 50 or 55, 56 sometimes on hotel standards as well. So, Marriott's, the Hilton's, a core group as well, they all have very set standards for acoustics within their space. So if we look at a typical floor plan layout of a hotel, and we look at those wall systems, here's a graphical representation that between the rooms, we're looking at SDC 55, the corridor, we're looking at SDC 50, and for the service shafts there, we're looking at an SDC 50 as well. And we also got some other requirements. We've got some wet area performance requirements. We have mold requirements. So this is a typical thing that yourselves will look at, and us as a material supplier would look at, well, how do we come up with the best system to do this? So if you're going to do it in traditional construction of masonry, and getting back to mass law, where you have to double the mass to get a 6 dB improvement, you can see it's quite clearly in this example here for AAC. So a 125 mil thick AAC is going to give us an SDC of 40. 250 is going to give us a 45. So we've doubled that mass and we've just got a 5 dB improvement. There's other things you can do on that wall to improve it. You can, again, you can improve the mass, you can increase the thickness, you can upgrade that wall by putting plasterboard on it with insulation, by lining it to improve it. You can create a twin stud wall, putting an air gap in there and creating 2 separate walls. So you see there, the bottom one is a 240 mil wall twin stud that's giving us an SDC of 50. Just as a little point of interest, the column on the left, RW plus CTR, is actually the low frequency noise adjustment. So I mentioned before that even at an STC 50, low frequency noise will still get through. So the actual STC, or the RW plus CTR rating, which is an adjustment to allow for that low frequency noise, you can see the number is quite significantly dropped. So when we pull in that low frequency noise adjustment, our actual overall drops. But you see, to get to an STC 55, we're going to a double skin brick at 390 mil thick. But the actual, taking account for the low frequency noise, we're still only at a 49. And so right up to a 540 mil twin stud wall using 250 mil brick with an STC 59. So we're getting very large walls, right? We're also getting a lot of mass to that structure as well. So that comes into the overall structural design of the building. And particularly also in some areas, not so much in Malaysia, but we are seeing more and more now in Indonesia from an earthquake side. So, there's high earthquake areas through Indonesia, and what we're seeing is that, that mass that's added to that building just adds to the acceleration and the force. So, they really are looking in set areas, how can they reduce the mass of that building to reduce the impact of earthquakes. So looking at another option here for the walls, if we looked at a cavity wall system, a drywall system, this is an STC 55 wall for the intertenancy or the room-to-room. Here we've got a 156 mil thick wall. So we've significantly reduced that wall thickness, but still achieving the STC 55. And we can do that because we've got different materials, we've got a cavity gap, we've got insulation, we're getting away. Mass law works for the linings, but we're working in these different areas of acoustics and using the material science to improve the STC without just relying on mass. So you can see there a similar system, a masonry system, would be 390 mil thick. And for the STC 50 wall, the room to corridor, we're down to 126. So we're actually always working to try to reduce that wall thickness. And we've got a couple projects that have been running now for probably a good 12 months to 18 months to really try to reduce this wall thickness, particularly on an STC 55. And various things our material science guys are working on to try to reduce that. So that's an area that's always in development, and we're always trying to reduce down the mass, reduce down the overall weight of the wall and the width, but maintain the performance. The other area to consider for hotels with traditional versus construction versus other materials is energy efficiency. So what we see in the region is new laws coming through dictating on energy efficiencies for buildings. So Singapore's got a plan to 2032 to dramatically reduce their energy consumption and efficiencies of buildings. We also see that coming through in Vietnam as well. And also into Thailand. We've seen that pretty significantly in Thailand, particularly in hotel construction. So what we're seeing in Thailand now is they've actually set a maximum overall thermal transfer value, so the amount of heat transfer through the building, the OTTV, at 30 watts per metre square. So if you look at a precast wall, that's giving generally a 40.09 watts per metre square. So compared to a cavity wall system for external use, which is down to 26.4. And again, just from a personal experience, so originally I was from New Zealand and then lived in Melbourne for 17 years before coming to KL. So quite a climate change, right, from the southern part of the world to the equator. And very warm, very humid here. But actually, I did personally notice quite a difference of the amount of heat that comes into our home compared to what I was experiencing before. So we're running our air conditioning all the time to control that climate. And if you put that into a commercial premises, the cost of that just escalates out. So this is why we're seeing in the regions more and more code change coming through to try to improve energy efficiency in buildings. And masonry generally is not a great, it's a good heat sink, but it's actually something that would absorb heat and then release it as well. The other area that we've been working in and getting involved in, and we see becoming more and more of a requirement, is Wi-Fi propagation. So I've got, again, a personal experience. I have teenage children, and thing that if we go to hotels, we go on a holiday, or even in our own home, the thing that our kids are most interested in is connectivity, right? The first thing they do is they look at their phone and what signal do I have in this space, right? They're not interested in anything else. They just, forget about the beautiful beach outside. It's can I get on the Snapchat? So we find that Wi-Fi propagation is becoming a thing. So hotels, we actually see that now flowing through in hotels is the standard for Wi-Fi propagation. So an actual a signal strength minimum that they want for any public open space. And the signal strength for Wi-Fi is measured in decibels, the same as it is for sound. Because Wi-Fi is just the same as sound, just the same as light. It all moves and propagates on a wave. So what they measure, what the Wi-Fi strength is in a decibel number. So we are seeing more and more standards coming through for this. And so we got involved in some testing of this. We got involved with a company called Ruckus, which is a US company that specializes in this area, but they have a pretty big office in Bangkok. So we worked with them there, looked at different materials. And with Wi-Fi also, what we see is generally these days two types of frequencies, so 2 gigahertz and 5 gigahertz routers. And the higher the frequency you go, the more material would start to interfere with that signal. So if you think about, we're back to acoustics and SDC, in that the wall performs, we measure from 125 hertz to 4,000 hertz. When we're talking Wi-Fi, we're getting up to gigahertz. So a hertz is the one wave per second. So when we're talking 4,000 hertz, we're talking about 4,000 wave frequencies in 1 second. Then we go kilohertz, we go megahertz, and we go gigahertz, where we're talking millions. So the good thing about Wi-Fi is that means we can transmit a lot of information very fast. I'm not too sure if that's me or not. So when you're getting into that sort of speed, when you're going up to 5 gigahertz on a wavelength, material starts to perform very differently than it does, say, the lower frequency range for acoustics. And what we find is that on the left-hand side of the graph there is that's a masonry AAC block. Blocked 99.99% of that 5 gigahertz signal, where a cavity wall system was sitting at around about 2 to 6%, depending on the SDC of the wall. So an SDC 50 wall for masonry is 99, where a drywall is 50. If we get to a 55, that drywall is blocking about 62%. But again, the difference is quite significant. So what we see as a footprint is, again, this is simulations that Ruckus did. And if you have one router in a room, you can see on the left-hand side there, AAC, the signal strength is relatively limited and drops off pretty fast. Where if we have a cavity wall system, a drywall system, we're getting much better coverage. And if we look at that from a hallway perspective, generally, especially 2 or 3 star hotels, in 4-star hotels, the routers are put into the hallways, and you see, what you end up with, if you've got traditional construction, you end up with a lot of blind spots, all right? And people are expecting to get Wi-Fi in their room in any part of the room, all right? So whether they're lying on the bed, sitting at the table, sitting on the toilet, right? Everyone wants to be able to get Wi-Fi. It doesn't matter where they are in that space. So using different materials can really affect that. And it does future-proof that building as well to a degree, because speeds are just going to get faster on the internet, right? We've got 5G or fifth generation Wi-Fi coming through. We're going to rely on that for the Internet of Things. Everything's going to be connected. So when we get into that space, material selection and how materials work, it's really, I think, it's an area we're going to see growing in regard to testing and people's knowledge in that space. So the other area we look at for hotel construction is productivity. So speed of construction. So hotel operators want to be able to open as quick as they can. Okay, so it's a commercial operation. The longer they're in construction, the less time they have to less time there is revenue coming in. But there's also, for a hotel, but every 7 years, they're refitting and redoing a room. So you're also looking at, productivity and also productivity and flexibility down the path to be able to modify that hotel or redesign it. So this is a study that the Singapore Building Construction Authority did a few years ago now. I think this is about 6 or 7 years ago, and they a whole lot of different materials, but they looked at the productivity, they looked at the durability, they looked at the overall performance of many different types of options for wall systems. So this is just a part of the study they did, but we can see there that when we look at a cavity wall system, a drywall compared to say brick, we're achieving 4 to 7 square meters per man per day, where with a drywall system we're getting up to 20 to 25 square meters a day installed. So it's a much faster process, right? So less impact on the project, a lot quicker construction, also a lot less mass into that building. So brick at 900 kilos, where we've got drywall at 113. The other thing that then comes into it is durability. So speed of construction is really good. We talk about Wi-Fi is really good. We talk about acoustics is really good, but durability is obviously a big thing as well. So how durable these walls. So again, this is where there are multiple options from a material selection perspective. So impact boards, various types of boards. So if we're looking at an impact board tested to the Singapore standard, is coming up as a severe duty performance, similar to brick. So really it's looking at that material selection and system selection to meet the overall performance you require. So quite often what we'll see is some sort of high performance. If we're going to a cavity wall system, for the hallways, we might see a high impact board to give us a severe duty. But within the room space, we might be dropping that back a bit to more of a fire-rated board, but maybe not with the durability factor. So these are all factors that that need to be taken into account. So for a hotel, if we looked at a double skin masonry wall, we're talking that is going to be 10 times slower than doing in a drywall system. So when we're just looking at challenging traditional construction methods through to ways of improving that productivity. So when we're looking at hotels, really the things to consider, just in summary, is think about the acoustics. Think about the acoustics between different applications, so room to room, the wet area applications, the service shafts is a big one, the corridors and the external walls as well, your curtain walls. Think about the energy efficiency, right? So what's the cost going to be to the operator of that hotel? It doesn't just apply to hotels. It could be a residential condo as well, or it could be an office building. What's the overall thermal performance of that building? And is that material selection and system going to improve it? Connectivity, is what's the connectivity or the use of the space going to be? coming into the age that we're in, where everything is connected by the internet, and we're relying more and more on connectivity. Again, from a personal experience, everything that my family does relies on the internet. Our TV, we don't watch free-to-air TV. We stream our TV with Netflix and Amazon and different services. All our music comes through from Spotify or online radio stations. Everything we do traditionally, we would have done another way from an entertainment perspective. But I just know I've seen the transformation of my family, as I mentioned with teenage kids, is that we operate in a completely different way than we did just 10 years ago. And productivity, speed of construction, the ability to have flexibility after construction. Particularly for a hotel operator, they need to keep the hotels fresh. They need to be changing the layout and possibly the floor plans, but generally every 7 years. And out of all these, what's our overall guest experience is going to be? The hotel to stay in business really needs those star ratings, right? So that is pretty much, I'm probably under time, but that's pretty much the presentation. So if we've got any questions, I think there's that session at the end for questions. But I appreciate your time. And if you've got questions, use the app again. We're talking about Wi-Fi and connectivity, right? Even the question time's relying on the internet and connectivity. So that'd be interesting to see how that goes. Okay, thank you.